Assalamualaikum. Hello guys. Okay, last week we have covered special probability distribution for discrete random variable, which are binomial and Poisson. So this week we are going to look on the continuous random variable, which is a special probability for a continuous random variable, which is normal distribution. Okay, let's start. Okay, a large number of phenomena in the world can be described or approximately described by normal distribution. So, for example, if you have an examination score of students, okay, so kalau if you look at Pasung punya examination score, okay, dia tak normal, definitely tak normal, okay. Sebabnya because you guys were chosen among the top students and most of you would get an A. So for example, the examination score of Pasung student, okay, the usual distribution untuk other scores lah, probably kat apa ni, in high school pun rasanya dalam 65 tu lah kot the mean, okay. Tapi you guys you all punya marks are not normal definitely. Sebab apa? Sebab you guys were selected from top students kan. So memang in our examination memang ramai lah dapat A, okay. So your mean would be somewhere around here. I think that's about 80 lah. So we have a skewed apa ni? We have a skewed distribution instead of normal untuk Pasung students, okay. Alright. Okay, and another example for a normal distribution is the weight of normal babies. Okay kan, sebab usually you know the weight of baby would be around what dulu-dulu kan, I think baby dulu dia ringan-ringan je about 2 kilos kan, tapi sekarang ni baby I think the mean is higher compared to last berapa like 50 years ago, sebab kita makan McD kot, so the mean is around 3 kilos, okay. Tapi my my baby and yang the third one she was 4.96 kan, almost 5 kilo besar. But yeah, okay. And then other example is the length of a type of leaf and amount of soda in drinks, okay. So it's 1:30 AM in the morning, so I buat video ni ngantuk gila. Okay, a normal probability distribution is a bell-shaped curve with the following characteristics. So the total area under the curve is 1, okay. So kalau you integrate, maksudnya you integrate from negative infinity to infinity, so you akan dapat the total area will be 1, okay. So the curve is symmetric about the mean, okay, meaning what? Kalau dia symmetric, okay, so half would be 0.5, another half of the curve would be 0.5, okay. So mean kat tengah-tengah. Alright, the two tails of the curve extend indefinitely. Okay, the thing about bell-shaped curve ni, okay, dia tak akan touch the axis lah, okay. Alright, and then there's always a chance, a really small chance that although the mean is 3, kan, for the weight of baby, tapi you rasa ada tak baby keluar berat dia 0.9? Ada je kan, okay. What about 0.7? Ada je kan, tapi it's the chances or the probability of getting a newborn baby with weight of 0.7 is like really small, but that's still a chance, okay. So dia it will extend indefinitely, okay, tapi it wouldn't touch 0, so there's still a slight chance. The curve is described as below, okay. You have the mean on the center, this is your x-axis, okay. So the standard deviation apa ni would determine whether your estimation of the mean tu will be precise ke tak. So the smaller your variance, kan, so which means all your data kan, okay, kalau you have a histogram, all your data clustered around the mean value. Okay, so normal distribution is identified by two parameters, okay. Kalau macam binomial, you have n and p, two parameters. Kalau Poisson, you only have one parameter, which is lambda, the mean. But for normal, you have two also, which is the mean and the standard variance, okay. So each different values of mean and variance give different normal distribution, different I think in the sense of the shape lah. The value of the mean determines the center of the distribution, whereas different values of sigma squared determines how much the observation is dispersed, okay. Alright, now let's look at the PDF of normal distribution. Variable x is said to follow normal distribution with mean, mu and variance denoted by this one, okay, if its probability density function is given by this one, okay. So you have 1 over sigma square root of 2 pi e to the power of negative half, x minus mu over sigma, the whole thing power 2, and x is from 90 infinity to infinity, and apa ni, the sigma must be a positive value lah, sebab yalah, standard deviation kan cannot be negative. Okay, now let's look at the properties of normal distribution. This one can be symmetric, so meaning half of the area on the left side of the mean will be 0.5, the other half will be 0.5, and each of the two shaded areas is very close to 0. Okay, and there's another thing about what we call as the 68, 95, 99.7 rule. Okay, maksud dia apa tau? You have the mean on the center at one standard deviation. You're gonna have 68%, 68.2 lah in to be precise. Okay, at 2 standard deviation you akan ada a total of 95.4. okay, and at 3 standard deviation you akan ada, kiranya maksudnya the data 99.7% of the data would lie between 3 standard deviation from the mean. So maksudnya mean minus 3 sigma, and also this one will be mean plus 3 sigma. Okay, so contohnya you ada mean sama dengan 10. Okay, so your standard deviation is 2. Okay, so at this is your mean. Okay, mean you is 2 at 1 standard deviation. Okay, 1 sigma lah kita panggil. Okay, so you akan ada value berapa? 10 tolak 2, which is 8 sampai 12. Okay, this is 1 standard 1 sigma. Okay, so you akan ada berapa? The data you 68.2% if your data is following x is following normal lah, normal 10 and 2 squared. Okay, so 68.2% of your data would lie between the value of 8 to 12. Okay, and then the apa ni, 95 rule tu at 2 standard error, at 2 standard deviation, so maksudnya you ada 8, 6 lah, 6 and 14. Okay, so can it looks like this. Okay, okay, so 95.4% of your data, okay, would lie between 6 to 14, so that would be 95.4%. Okay, so for 3 sigma you akan ada 4 sampai 16. Okay, so itulah maksudnya the 68, 95, 99.7 rule. Okay, okay, now let's look at how the different the values of mean and standard deviation would affect the shape of the normal distribution. So kalau if you have different values of standard deviation would represent the how much your data deviates from the mean ataupun the dispersion of the data lah. So kalau you ada besar the standard deviation, you akan ada macam, dia macam terpenyek sikit kan. Okay, so lagi kecil the standard deviation, dia akan macam lagi kurus lah, and all your data would clustered around the mean. Okay, so kalau you have different mean, okay, maksudnya location dia lain-lain lah. Okay kan, sebab kat sini kosong, 20, 30, 40 kan. Okay, so you would have a different location of the peak for the distribution. Okay, yang ni different mean, same apa ni, same standard deviation. So maksudnya if you want to estimate something, okay, you better have a small standard deviation so that you boleh somehow predict more precise, or do any forecasting more accurately with a smaller standard deviation. Okay, alright, now let's look at the first example. Okay, so if x follow normal 4, 9, find the probability of x greater than 8. Okay, so usually kalau you ada the PDF, okay, macam like what we used to learn in continuous random variable. So kalau you nak cari px greater than 8, so what you do is you integrate daripada 8 sampai infinity kan. Okay, of the fx, okay, dx. Okay, alright, so for Poisson dengan binomial, what you can do is that you boleh tengok statistical table of Murdoch and Barnes. Okay, so probably normal distribution ni pun ada table dia lah kot kan. Okay, tapi kan there's one problem actually. Kalau macam you tengok binomial kan, okay, binomial dia ada 2 parameters n and p. Okay, so tapi if you look at the table, not all values of n and not all values of p is tabulated in the table. Okay, so you imagine you ada normal, mean of 4 and variance 9. Okay, but you have to also take note that your X ni is actually a continuous random variable. So maksudnya there's always a chance whereby you would get your data X ni follow normal 4 and 9.01 or 9.00001. Okay, so your X ni is actually from negative infinity to infinity. It can take up any values. Okay, so if you want to tabulate 4.9.01 memang banyak lah kan, you punya table you akan like being endless lah kan, sebab there's many combination of mean and variance. Okay, so it's not possible for you to get or it's not possible for you to tabulate the normal distribution with parameter mean and variance. Okay, one way to simplify the tabulation of the normal probabilities is that by using the standard normal distribution. So if you have whatever values of mean, okay, and sigma, you can always do some sort of you macam do a standardization. Okay, so you what you do is that you tolak this is the formula untuk you standardize the normal random variable X. Okay, so what you do is you minus mu you over the sigma. Okay, so when you standardize the random variable X, so you denote as Z kan. So Z ni would follow standard normal distribution, which is with mean 0 and standard variance standard deviation or variance 1. Okay, so I'll give you the example just now. So kata you have X follow normal 4, 9. Okay, you want to find what is the probability of X greater than 8. Okay, so what you can do is that you kena standardize the random variable X dulu by what X greater than 8 kan. You minus the mu. Okay, you minus what is your mean 4 kan. Okay, you divide by your standard deviation, and then here you divide by 3 lah. Okay, your standard deviation. So X minus mu over sigma ni kan. Okay, just now here this is equals to Z kan. So you're gonna have Z greater than 1.333. Okay, so and this Z is actually following normal standard normal with mean 0 and variance 1. If for whatever values of mean mu and sigma, okay, you can always transform your variable X to a standard normal. So we are going to have a one simple table which give you all the probabilities for standard normal. Okay, so let's have a look at the table for normal distribution. Okay, so this is your table for standard normal. Okay, mana kau? Okay, so the shaded area is actually the probability of P Z greater than Z. Okay, so for instance, if you are looking for P Z greater than 0.3, okay, so you would have your probability as 0.38 to 1. Okay, so kalau you nak P Z greater than 0.35, okay, so your probability will be here kan, sebab dia 0.3 plus 0.05, so you're going to get 0.35. Okay, you akan dapat lah macam tu. Your answer will be 0.3632. Okay, so that is how you look for a standard normal probabilities. Okay, alright, so dia ada PZ greater than 4 je. So 4, 5, 6 saja. So other than greater than 6, the probability would be really close to 0. Okay. Now we have the example 19.2. Okay. So if X is following normal distribution with mean 4 and variance 9, find using the standard normal table of Px greater or equal than 8. Okay. So if you want to have X greater or equal than 8, okay, so you can standardize the X by you minus mu, maksudnya 8 you akan tolak 4 over sigma. So you akan over yang 9 ni is actually your variance yang ni is your variance. So variance is 9, so your standard deviation will be square root of 9, which is 3 lah. So your sigma will be 3. Okay, so then you akan ada X minus mu over sigma ni is actually Z kan. Z would follow standard normal mean 0 and variance 1. Okay, so you akan dapat 1.3333 kan. Okay, so when you look at your statistical table, okay, you want the you have the z value, which is 1.33. Okay, 1.33. So your answer will be 0.0918. Okay, so your answer will be 0.0918. Okay, alright. And then kalau you wanna find p x less or equal than 5. Okay, so this would be you transform to standard normal dulu. So you akan dapat berapa x minus mu over sigma will be less or equal than 5 minus 4 over 3. Okay, so you akan dapat pz less or equal than berapa? 0.333. Okay. Okay. Tapi kalau if you look at the statistical table kan, the statistical table give you the probability of z greater than z kan. Okay. So you kena tukar sikit lah this one. So kalau if you draw the curve kan, so z sini kosong kan, sini kosong, standard normal 0.3 will be 0.3333 somewhere here. So you want z less than 0.003. So the whole big area ni lah yang you nak. Okay, so kalau you tengok standard normal kan, standard normal half of the curve will be 0.5 and 0.5 kan. Okay, sebab the total area is 1. So kalau you tengok ni, the shaded area is actually will be greater than 0.5. Okay, so that's just your estimate lah. Okay, tapi how do you get the exact probability or the shaded area? Using the statistical table. Okay, so what you can do is that z less than 0.03 is actually equivalent to 1 minus probability of z greater or equal than 0.333. Okay, alright, so you can use the statistical table. 0.333 will be 0.3707. Okay, so you akan tolak 1, tolak 0.3707. So you akan dapat jawapan you will be 0.6293. Okay, so that's going to be your answer. Alright, that's another thing that I want you to take note. Okay, so kalau you tengok probability kan of the normal distribution given in this table, so the highest probability yang you akan dapat is only berapa? Ini 0.00 ni small kan, and the highest probability that you will get is 0.5. So maksudnya the table is only giving you the half of the distribution. Dia akan bagi the yalah sampai 0.5 je lah. Sebabnya is because this is symmetric kan. Katalah you have yang ni 0 kan, 0.3. Okay, you want the property of x greater than 0.3. So this would be equivalent to x z less than negative 0.3. Okay, so sebab this symmetrical, so the probability of z greater than 0.3 akan sama dengan the probability of z less than negative 0.3. Okay, example C. So you want to find x in between 4 and 6. Okay, yang ni equal sign dengan tak ada equal sign, it does not matter sebab x is continuous random variable kan. Okay, so this would be equivalent to x minus mu over sigma. So meaning that 4 ni you kena tolak dengan min u which is 4 bagi dengan sigma u is 3. Okay, yang also 6 ni pun you have to minus 4 over 3. Okay, so you akan dapat p z in between 0 to 0.6667. Okay, alright, so kalau you draw the bell shape. Okay, so sekarang your z ni is following standard normal kan. Okay, so you ada 0 kat on the center. Okay, so you nak z from 0 to 0.667. So you nak this shaded area saja. Okay, so how do you get your shaded area? Sebab your statistical book only give you the probability of x greater than z kan. Okay, so what you can do is that you boleh get the probability of z greater than 0 minus probability of z greater than 0.6667. Okay, so nanti greater than 0, okay, tolak dengan greater than 0.667, you akan dapat this shaded area, okay. But what is the property of Z greater than 0? Sebab dia it's a symmetrical, so greater than 0, it's half of the curve, okay, so you akan dapat 0.5. Kalau you tengok statistic table pun sama juga. So for Z 0, you akan dapat the property is 0.5, okay. So minus Z greater than 0.667 will be 0.2514. So you akan dapat 0.2486. Okay. So that's for C. D pula, Px greater or equal than 3. Yang ni pun sama macam A juga. Okay. Tapi interestingly, you akan ada jawapan dia akan sama dengan negatif. Tak silap. Okay. So for D, you have Px greater or equal than 3. So this one will be equivalent to x minus mu over sigma 3 minus 4 over 3 kan. So you akan ada Pz greater than negative 1 over 3. Okay. So kalau if you draw the bell shape kan, standard normal, Z ni kan standard normal, mean will be 0 on the center. Negative 1/3 is somewhere on your left side. So you nak Z greater than negative 1 over 3. So meaning you have this whole area. Okay. So yang ni will be equivalent to what? How do you get the shaded area? Okay. So but remember that your statistical table is only giving you half of the bell shape saja. Okay. And it gives you the property of Z greater than Z. Okay. So what you can do is that you boleh buat 1 minus probability of Z greater than 1 over 3 lah kan, sebab this is symmetry. So this one you boleh juga lukis sama macam ni. Ni kosong 1/3. So you akan ada shaded area kat sini. Okay, dia sama je. Okay. So okay. So you akan ataupun what you can do is that kan, you boleh buat 0, itu susah pula kan. Okay. So you will get 1 minus Z greater than 1 over 3 will be 0.3707. Okay. You akan dapat 0.6293. Okay. Alright, so that's for D. Okay. Untuk E, you will have the property of X less or equal than 2. Okay. So sebab X is following normal 4 and 9 kan, tapi we don't have table for mean 4 and variance 9. We only have Z kan, which is normal 0, 1. So we change X and standardizing the X to Z. Okay. So we do that by minus mu and over sigma. So 2 will be minus 4 over 3. So you akan dapat Pz less or equal than negative 2 over 3. So if you draw the standard normal, kosong kat tengah, you have Z less than negative 2 over 3. Okay. So you nak Z less than that. Okay. Sebab dia symmetry, so whatever on the negative value sebenarnya akan sama dengan kalau you have 2 over 3 and you find the property of Z greater than, this will be equivalent Z greater or equal than 2 over 3. So you can look at the statistical table and you will get Z greater than 2 over 3 will be 0.2514. Okay. Alright, so that's E. What about F? Okay, F. So for F, we are looking for X from 1 to 3. Okay. So kita buat standard normal. We change to standard normal. So Z will be in between 1 minus 4 over 3. And it will be 3 minus 4 over 3. Okay. So you akan ada P Z in between negative 1 and negative 0.3333. Okay. So if you draw the bell shape of standard normal, so kosong kat tengah, you have negative 1 okay, so negative 0.33 dulu. Okay, kat sini negative 1 is somewhere here. Okay, so you want in between this. Okay. Alright. Okay, so sebab the standard normal kan, it's a symmetric shape. So this one will be equivalent to bila you ada 0.33 kat sini dengan 1. So in between 0.332, dia akan sama dengan P Z in between 0.333 sampai 1. Betul tak? Okay. Alright, so to get Z in between 0.333 hingga 1, what you can do is that this would be equivalent to Z ni you greater than 0.3333, okay. You tolak dengan property of Z greater than 1, okay. So you will get in between there. Okay, so if you look at the statistical book, Z greater than 0.33 would be 0.3707. You minus Z greater than 1 would be 0.1587. So you akan dapat 0.212. Okay, so that's F. Okay. Okay, so what about G? Okay, if you have G, P, X in between 2 and 5, okay. So, because we don't have a table for X, mean 4 and 9, so kita standardize here. Z will be in between 2 minus 4 over 3 will be negative 2 over 3. 5 minus 4 over 3 will be 1 over 3, okay. So you need Z standard normal 0 on the center. Negative 2 over 3 is on your left side, 1 over 3 is on your right side, so you know this area, okay. So how do you get this area given that in your statistical table you only have property of Z greater than the value of Z, okay. So that would be I think kalau nak senang yang ni kan, this will be 1 minus the area on your right hand side will be PZ greater than 1 over 3. Okay, tapi you have to also minus the small area on your left hand side, which is property of Z less than negative 2 over 3. Tapi if you sebab this is symmetric distribution, Z less than negative 2 over 3 akan sama dengan property of Z greater than 2 over 3. Kita positif kan, okay, sama je kan. So yang ni akan dapat benda yang sama lah, 1 over 3. So nanti you will get your answer as 1 minus 0.2514 minus 0.3707. So you akan dapat 0.3779 as your answer. Okay. Alright. Okay. So now for question H, okay. So you have X minus 4 less or equal than 2, okay. So you akan ada P X less than 2, dia akan sebenarnya X tolak 4 in between negative 2 and 2. Okay, agree? Alright. So so your probability of X will be in between what? Negative 4 ni you kena tambahkan lah on both sides. So negative 2 tambah 2 tambah 4, and also here 2 tambah 4. Okay, so you akan ada P of X in between 2 and 6. Okay. Alright, tapi your X is following normal for 9. Okay, we don't have the table for X. We only have standard normal. So we change X to Z. Okay, X minus mu over sigma. You akan dapat 2 tolak 4 per 3, 6 tolak 4 per 3. So you will have P, Z in between negative 2 over 3 sampai 2 over 3. Okay, so if you draw the bell shape, okay, 0 on the center, you ada negative 2 over 3 here, 2 over 3. So you want the area between these two equal values, okay. So there are two things that you can do. It's either you buat 1 minus P Z greater than 2 over 3, okay, tolak P Z less than negative 2 over 3. Okay, tapi you tahu Z less than 2 over 3 kan, this area and also this area adalah sama. Okay, okay, so practically what you do is you tolak 1 minus 2 kali of probability of Z greater than 2 over 3. Okay, ataupun what you can do is that you boleh buat you cari half of it dulu, which is 0.5 yang ni kan. This one can be also equal to 0.5 tolak P of Z greater than 2 over 3 kan. Okay, tapi yang ni you tahu this one the area is the same kan, left and right, so you boleh 2 kali of this area, so you akan dapat jawapan yang sama je. Yang ni you akan dapat berapa 0.4911. Sama juga, yang ni pun you akan dapat 0.4 0.4911. Okay. Okay, so last question is that find the value of M if Px greater or equal than M is 0.1151. So maksudnya here kan, you have a value of M, okay, probability you ada 0.1151. Okay, so X, you tak ada standard table of X, so you have to switch to Z dulu. So P X greater or equal than M is equals to 0.1151. Okay, so kalau kita make a standard normal, so Z ni will be equivalent greater than M minus 4 over 3. Okay, agree? Okay. So this one will be equivalent to 0.51151. Okay. So maksudnya you have Z ni is a standard normal, kosong kan on the center. So Z, you tengok probability ni is less than 0.5 kan. So maksudnya the probability will probably macam this big aja lah kan. So yang ni will be 0.1151 the area. So the value here kan, the Z value here is actually M tolak 4 per 3. Okay. So kalau so you rasa kan, so it's not possible to have your M minus 4 over 3 tu on your left hand side. Sebab kalau your value of this one kan, katalah I denote this as A kan, katalah the value of A ni is on your left side, Z greater than A kan, okay, you akan have the whole big area here, Z greater than A kan. Whereas the probability is less than 0.5 kan, so you only have a small area, not a big area. Okay, so you know that A ni is on your right hand side. Okay. Okay, so here to get the value of M, okay, but you tahu the probability is 0.1151. Okay, so you look at your statistical table. So 0.1151 is somewhere here, 0.11 0.1151 mana? 0.11 yang ni 3151. Okay, so 0.1151 is actually your Z value will be 1.20. Okay, so maksudnya, so meaning that this value is actually equivalent to 1.2. Okay, so A ni will be equivalent to 1.2. Okay, so A ni is M minus 4 over 3. This one will be equivalent to 1.2 sebab kita nak cari the value of M, bukannya cari value of A. Okay, so you multiply 3 with 1.2 plus 4, so your M will be equivalent to 7.6. Okay, so that's how you get your value of M. Okay, so we have another, ada banyak lagi slide ke? Ada mana? Okay, sikit je lagi. Okay, nak tidur dah. Okay, you have the lifespan of a calculator has a normal distribution will mean 60 months and a standard deviation of 5 months. Okay, so kita boleh denote X ni as calculator lifespan. Okay, okay. So X follow normal with mean 60 and standard deviation 5 power 2. If a calculator is randomly selected, find the probability that the calculator has a lifespan of more than 7 months. So you nak cari PX greater than 7 months. Okay, so sebab we don't have the table for X 60 and sigma 5, we only have standard normal 0, 1. So kita tukar X to Z. Okay, so Z will be greater than 7 minus your mean is sorry, ni 7 months kan. So 7 months okay, betul lah. So 7 minus 60 over 5 lah. Okay, sorry lah, soalan ni salah lah. 70, sorry, 70 months. Okay, so 70 tolak 60 per 5, so you akan dapat PZ greater than 2. Okay, PZ greater than 2, you look at your statistical table, straight away you can get 0.0228. The next 2 Roman between 6 years to 4 years. So 6 years is equivalent to berapa? 48 bulan. 6 years is equivalent to 60 months. Okay, so you want to find for second 2 Roman, you want to find X in between 48 to 60 kan. Okay, so X ni kita tukar to standard normal. Okay, so it will be 48 tolak mean you 60 over 5. This one will be 60 minus 60 over 5. Okay, so you akan ada PZ in between, yang ni 0. On your left hand side, sorry, ini 72, ya Allah, 72. Okay, sorry, 72. Yang ni on your right hand side you akan dapat 2.4. On on your left hand side you dapat negative 2.4. Okay. Alright, so this is how it looks like. Standard normal, negative 2.4 on your left, 2.4 on your right. Okay, so you want the area in between these two values. Okay, so what we can do is that this is equivalent to the total area, total probability, tolak dengan the small area on your right hand side, which is PZ greater than 2.4. Okay, tapi the area on your left hand side ni is actually equivalent to the small area on your right hand side. So you dua kali of the PZ greater than 2.4 lah. So you akan dapat 0.9836. Question B, a calculator that starts malfunctioning within 3.5 years of the purchase will be replaced by a new one. So 3.5 year is actually equivalent to 42 months. Okay, find the percentage of calculators that are expected to be replaced. Okay, so you need to find P, X, kiranya functioning, dia dapat baru kalau dia malfunctioning, and means it is lesser than the warranty month lah, which is 3.5 years times 12, which is 42 kan. Okay, 42 months, you get a new one. Okay, so so what is the percentage of the calculator that need to be replaced? It will be PZ less than 42 minus 60 over 5. Okay, so you will get PZ less than negative 3.6. Okay, so negative 3.6 is on your left hand side. Okay, so you want that small area. This is actually equivalent to Z greater than 3.6. Okay, so you look at the statistical table, you akan dapat 0.00016. Okay, so that's your answer. Baguslah calculator ni, small apa ni, probability of malfunctioning. Okay, tapi dia minta ada percentage kan, so percentage you kena darab apa ni 100%. So the percentage will be 0.016%. Okay, so that's a percentage. Okay, so that's all for normal distribution. Okay, so let's recap. Alright, so basically to get the probability of normal distribution, we couldn't afford to tabulate all possible values of mean and sigma. Okay, because it's it can be 4.01, it can be 4.001, because the values are continuous random variable kan, so it can be infinitely many lah. Okay, so what we can do is that we only have the standard normal distribution, whereby the mean is 0 and the standard deviation is 1. So for whatever values of mean and sigma, you have to convert to standard normal, so that you can only look at the standard normal table and you will be able to get the probability from normal distribution. Okay, so that's all for this week. We will have another week on the approximation of normal and Poisson using normal distribution. Okay, and Dr. Farida will come in and continue on the matrices. Okay, on the topic of matrices. Okay, thank you so much guys. Assalamualaikum. Bye bye.